Let's look at another example for the theoretical calculations of the metacentric height. We have a pontoon 50 meters long, 7 meters wide, and 3 meters high, with a weight of the 700,000 newtons unloaded situation, and carries a load of the 1600,000 newtons or 1600 kilonewtons. The load is placed symmetrically on the pontoon so that its center of gravity is on the longitudinal center line at a height of the half a meters above the deck, which is 3.5 meters above the base. Imagine that's like a half a meter. That's the center of the gravity of the load, and the overall center of the gravity of the pontoon with the load is equal to the 3.5 meters above the base once the pontoon is loaded. The center of the gravity of the pontoon can be based or can be assumed to be on the longitudinal center line at a height of the 1.5 meters above the base. Okay, imagine at the pontoon itself is exactly located at the half of that, 1.5 meters, and the load is like the half a meters above the deck. So the pontoon floats in saline water of the density of the 1025 kilograms per cubic meter. So the question here is to calculate metacentric height of the pontoon. Okay, so let's look at this example. First of all, based on the Archimedes principle and the buoyancy force, we need to calculate the H, and then we need to calculate the finally the GM. If the GM is greater than 0, which says life is stable. Let's look at this, how we're just going to calculate everything in this case. So we're just going to need to just take into account both loads together, like the 700, 1600 together is like a 2300,000 newtons or the kilonewtons. So 2300 kilonewtons is like the total weight. And we can easily calculate the water of the seawater displaced, which is like the V is equal to the total weight divided by the weight density. Imagine we have like the total weight like a 2300,000 newtons divided by the weight, which is like the row of the water, like 1025 times the G, like the 9.81. Just bear in mind the difference between this formula and the formula that we used to have was that the terms here is like that rather than the mass, we just use the newtons. Don't freak out once you're just going to see here. If the total weight is given based on not mass, based on the weight at the denominator, rather than like the rho that we used to have, you can just use rho G or the specific weight or the weight density. Okay. So you're just gonna, if you're just gonna have top of that, the weight is not the mass, like is the weight based on the newtons. So 2300 thousandths, okay? So divided by density, 1025 times G, gravity, acceleration. So the result is 228.74 cubic meters. So this is like 228 the seawater displaced. And if that figure is divided by the pontoon plan is like a 15 times 7. So the depth of immersion is equal to 2.18 meters, which is like the H in this figure on the right hand side. The half of that, like the H second, is like the divided by 2 is equal to 1.09 meters, which is like the OB. Okay, once you're just gonna have the OB, the other point here is to identify the point G. Okay, we know that the weight is located like the center of the gravity for the load is like the 3.5 meters above the base, and the gravity of the pontoon itself is like the 1.5 above the base. So we're just going to take the moment about that point to calculate the center of the gravity of the whole. We're just going to take the moment about point O for two loads. Okay, just bear in mind for these two, we're just going to use the same like the method that we used it in the past. On the right hand side, which is the weight or the mass times the lever arm, which is like the if the reference line is like the base, is like the weight of the load, which is like the 1600. Just get back to this example. The load is like the 1600,000, or 1600,000 times the lever arm, which is the 3.5 meters from the base. Okay, 3 meters this one, half a meter is to get to like the center of that load. This is like the moment of this one plus the moment of the pontoon itself is like the 700. 700 is the load of the pontoon. If the weight of the pontoon, 700,000 times lever arm for that one is like the center of the buoyancy, center of the gravity from that point to the base is like the 1.5 meters, which is 3 meters. Like the depth of the pontoon is like a 1.5 meters. And this is like the right hand side. On the left hand side, we're just gonna say like the OG is the resultant center of the gravity times the overall force. The overall force, the total force, is equal to the like a both weights together, which is like the 2,300 thousandths. Okay, what's you're just gonna have on the left hand side? If you're just gonna rearrange the like the left hand side like coefficient to the right hand side at the bottom of the ratio, you're just gonna calculate easily OG, which is equal to 2.89 meters. If we just kind of like an OG 2.5 meters minus OB, which we calculated before, which is 1.09, the BG can be easily calculated 1.8 meters or 80 meters. So we have like the BG here. So to calculate the rest of the formula, we need to just calculate the BM. So the BG is calculated here. If you're just going to have the BM based on the formula, taking it from the BJ is taken away from that one, you can easily calculate the GM. The BM, we know the formula for that. The BM is I, second moment of the area, divided by the volume of the water displaced. Second moment of the area, like the LB cubed over 12. So L is like the length, is like a 15 times the 7 cubed over 12 times the water of the volume displaced, 228.74. So the BM is equal to like the 1.87 meters. So once you just kind of like the BM, you can subtract the BG that you calculated before, 1.8. So taking away from 1.87, which is equal to 0.07 meters. So this is like the metacentric height. This figure is really close to zero because the value is really small, very small. We're just going to say this is close to the condition of the neutral stability, which could be unacceptable. So you're not going to just accept this one all the time. For the safety reason, you need to just take this like the much larger, like the previous example, at least more than 1 meter. So you just need to just bear in mind this is very important as well.